Great, this video we're going to be reviewing adding and subtracting numbers in scientific notation. So we've done a lot of work with this. I just want to go back and recover it. But adding and subtracting, a couple things to keep in mind. Your exponents have to be the same before you can add or subtract them. So your exponents must be the same. And then whenever you are ready to add and subtract, that exponent will then be the same as the answer as that it was in the problem. So we'll do some examples here and refresh your brains on those. So let's look here at example 1. We have 4.2 times 10 to the 7th. So this is in scientific notation. Remember, this first number is between 1 and 10. It's times 10 to some exponent. So we have 4.2 times 10 to the 7th plus 3.7 times 10 to the 7th. So my first question should be, are the exponents the same? And yes, they are. They are both 7. So then I can just go ahead and work the problem. Well, it is an addition problem, so I'm going to add my two decimal numbers, 4.2 and 3.7. When I add those together, I get 7.9. So that's part is 7.9, and here's what I was talking about previously. Since the problem, they're both 10 to the 7th, it's going to stay 10 to the 7th. You do not add those exponents together, it stays the same. You only add the two decimal numbers. So 7.9 times 10 to the 7th is our answer. Okay, let's look at the next one. Number 2. We have 9.8 times 10 to the 11th minus 7.2 times 10 to the 11th. So my first question, are my exponents the same? So yes, they are both 11. So I know in my answer I'll have times 10 to the 11th. And then I'm just going to go ahead and work with the two decimal numbers. Now, this is a subtraction problem. So I'm going to do 9.8 minus 7.2. So 8 minus 2 is 6. 9 minus 7 is 2. So this would be 2.6 times 10 to the 11. And yes, this number is between 1 and 10, so we are good to go. Okay, number 3. We have 3.9 times 10 to the 2nd plus 5.3 times 10 to the 3rd. So on this one, notice your two exponents are different. Your number one priority is to get those the same. Now, I can either change this one to a 3 or change this one to a 2. It doesn't matter which one you do. So let's say I want to make this one a 3. So I'm going to add 1 to my exponent. So that will become 10 to the 3rd. Now this one is already 10 to the 3rd, so nothing's going to change about this one. But what is going to change over here is my decimal number, the 3.9. Since I added 1 to the exponent, I'm actually going to take my decimal and move it back 1. So now this is going to be 0.39 times 10 to the 3rd. And yes, I know that's not in scientific notation, but we need to do that in order to get the problem solved. So now that my exponents are the same, I can go ahead and I'm going to add my two decimal numbers. So I have 5.3 and 0.39. Remember, you need to line up your decimal points when you add or subtract. Okay, well, nothing plus 9 is 9. 3 and 3 is 6. 5 and nothing is 5. So we have 5.69, and then what happens with the times 10? Well, that exponent's going to stay 3. And then your final check, is this between 1 and 10? 5.69 is between 1 and 10, so we are good there. There's our answer. Okay, example number 4. We have 8.8 times 10 to the 9th. Minus 7.3 times 10 to the 7th. So again, my first question, are the exponents the same? And no, they are not. So we need to make them the same. Now, whether you make this a 7 or this a 9, or change them both to 8s. It really doesn't matter. It's your own preference. So let's say I am going to change this one to a 7. So to make 9 7, I'm actually going to subtract 2. And when I subtract 2, I'm actually going to move my decimal to the right 2 places. And then I'll have to add in a 0 there. So now this becomes 880, and my decimal is right after that 0. Okay, this one already has an exponent of 7, so I don't need to change anything about this one. Okay, and now that they're the same, I'm ready to subtract. So I'm going to take 880 minus 7.3. So remember, you have to line up your decimals here. Got to do some borrowing. So you end up getting 872.7. And then again, my times 10 to the 7th stays that way. Now, on this one, this number, 872.7, is not between 1 and 10. And for this to be in proper scientific notation, it has to be. So I need my decimal to be moved 2 places to the left, so that is now 8.727. Now that's between 1 and 10. And when I do that, since I moved it to the left, I'm actually going to add 2 to my exponent. So now it will become a 9. That is my final answer.